Good afternoon, colleagues, boys and girls. My name is Mr. Nkwedi. I'm a deputy principal at Lukulong, also teaching mathematics in grade 12. Our focus for this afternoon is going to be on inverse functions. Boys and girls, grab your pens and your books because we are going to work. This is the time that we are using for revision. We are not teaching this time. We are going to treat different question papers on inverse function. The first question paper I'm having in front of me is of November 2009. The first question that I'm having this afternoon is of November 2009. I hope we can all see it. And we are going to start with question 5. And it reads as follows. Sketched below are the graphs of f of x, which is equals to 2 to the power of x, and g of x, which is equals to negative in bracket x minus 1 all squared plus b, where b is a constant. The graphs of f and g intersect the y-axis at c. I hope we can all see that. And d, and hence d becomes the turning point of of the parabole, which is g, the graph of g. Our first question in this regard is, you are expected to show that b is equals to 2. Now, our point of departure is, where could be the letter b, small b, be found? If we check on the two functions, we are having f of x, which is 2 to power of x. Unfortunately, we don't have b here. And the second function is g of x, which is equals to negative in bracket x minus 1 all squared plus b. And this is where b is. So we are expected to confirm, to show, because when they say this, they say show that b is equals to 2. Confirm with them that indeed b is equals to 2. And b appears, it's a parameter of what graph? Of the quadratic graph. So we must determine the value of b. Now, what we need to do in this regard is to say, what is it that we are given on the graph? Let's check on what is given on us on the graph. We are given point C and point D. Both points fall on the two graphs, that is the f of x and the g of x. However, b, the parameter b, it's of the quadratic graph, the parabole. Now what we need to do is to say, are we given the coordinates for these points? When we don't have coordinates, we don't have the coordinate of d, we don't have the coordinate of c. However, it's easy for us to can determine the coordinate of c, since c becomes the y-intercept for the two graphs. Firstly, we cannot get the equation, that is the coordinates for c of this graph, of the parabole. However, it is easy for us to can determine this, because if we check on this, we realize that, okay, for this exponential graph, the graph must always, that is the exponential graph must always cut this, the y-axis at a point where the coordinates are 0 and 1. At the point where coordinates are 0 and 1. So coincidentally, both graphs share this point, because that is where both of them intersect. Now for us to determine b is to say, let us use the coordinates of point C, which we were not given, but we had to think about them since this, because of this graph being an exponential graph. We know that exponential graph always cuts the y-axis at the point 0 and 1. So we are going to use these coordinates. Having to say our y is going to be equals to 0. So if we let y to be equals to 0, we say 0 will be equals to negative in bracket, x is 1 minus 1 all squared plus b, all squared plus b. Now what we need to do in this case is we have let this is, what is this? We have let this to be equals to 1. X at that point is equals to 1. X is equals to 1. So I wish we work together on this. We work together on this. Can we, let's take a minute to work it out and check as to whether can't we arrive at the correct answer. Oh yes, my substitution. I just realized that my substitution was incorrect. In fact, what I should have done was to say y, because we have a point at which we're having a point that consists of 0 and 1. So it is indeed y which is equals to 1, not what I've written here. So we're having 1, which we say is equals to minus in bracket x is 0 minus 1 all squared plus b. Then what we do in this case is to say if we subtract 1 from 0 is going to be negative 1. Negative 1 all squared is 1. But we have negative outside, so we're having 1 which we say is equals to negative 1 plus b. So when we transpose the negative 1 is going to be positive, so it means indeed b is equals to 2. Indeed b is equals to 2. So let's forget that one. Let's forget that one. Let me revise. Let me repeat what let me show you. Let me repeat what I've done. I'm saying at this point we having in fact we having 2 points which coincidentally both graphs intersect at point D and point C. So it was going to be difficult for us to determine the coordinates of point D, but it was always going to be very easy for us to determine the coordinates of point C, because coordinates of point C, coincidentally, the y coordinate thereof becomes the y coordinate becomes y since this graph is exponential. Since this graph is an exponential graph. So indeed I've used this points, the coordinates of that point to have arrived at this, wherein I've said that, okay, if x, if this is my x and this is my y, I go back to the formula to say my g of x, which is y, I just substituted that with 1, then I did the substitution wherein x was substituted with 0, then so that I can eventually get the value of b. So this is the correct value of b, which confirms what these people were looking for, or the examiner was looking for. Right, can we go to 5.2? 5.2 says write down the coordinates of the turning point of G. Right, now what we need to do, it means after I have determined the value of b, it means this is how the graph is going to look like. My g of x will look like minus in bracket x minus 1 all squared plus 2, because this 2 I would have substituted it with, this b would have been substituted by the 2. So this is how the graph, the equation of the parabole, this parabole looks like. Fine. Now going back to question 2, 5.2, it says write down the coordinates of the turning point of G. The turning point of G. This is the parabole, the turning point of G. And D, which is the turning point of G. So in essence, what we are looking for here is the coordinates, both the x and the y of this. Let's check on that. The mark allocation is just 2 marks. Now what we need to do, yes, the first step was to write this. It is always easy to write down the coordinates of the turning point if it is written like this, as compared to when it is written in this form. Remember, we have 2 forms of having to write the quadratic equations. Either it's this form or it's a into x plus p all squared plus q. So this time it's written in this form. Then we know that if it is written in this form, we do not have a problem of having to determine the coordinates of the turning point, since the coordinates of the turning point are going to be P and Q. So now if we go back to our graph, the equation of the graph, it reads as g of x being equals to negative in bracket x minus 1 all squared plus 2. Now, from this, we must identify the P and the Q. And P will be this one when Q is that one. Now, it means here, for us to determine the coordinates of the turning point, you say the coordinates of the turning point of G will be this one. Remember, it's written x minus 1. So when we solve for x, we say x is equals to 1 because we are transposing. So it's 1 and 2. 1 and 2, which are values of P and Q. Which are values of P and Q. So that is when we were answering 5.2. Let's go to 5.3. 5.3 talks about expect us to write down the equation of f prime of negative 1 in the form of y. It means they want the inverse of what graph? The inverse of this. The inverse. They are specific because they are saying the inverse of this. They didn't, for now they didn't talk about the inverse of g of x. Rather, they are talking about the inverse of f of x. Right. Now, let's have a look. What is our f of x? The f of x. F of x for us is f of x is equals to f of x is equals to 2 to the power of x. That is when we are answering 5.3. In answering 5.3, f of x is equals to 2 to the power of x. This equation is an equation. It's an exponential equation function. It's an equation. It's an equation of an exponential graph. It's an equation of an exponential graph. So every time when I teach this part, I normally say to my learners, if you struggle in having to determine the equation of the inverse of an exponential, it will always be easy if you recall that the base of an exponent will remain the base of a log, because the inverse of an exponent is actually a log. So now, if this 2 is a base of an exponent, this 2 will remain the base of a log. All right, let's do this. Let's say f of x is a y. You say y will be equals to 2 to the power of x. We know the long story of having to interchange x with y, wherein we are going to have y, x being equals to 2 to power of y. Now when we arrive here, we say you must always turn y to be the subject of the formula. Hence when we come here, now you will have to introduce the log. But when you introduce the log, please remember that this base of an exponent will always be the base for the log, such that eventually when you write this expression, it's going to look like this. Y is going to be equals to log to base 2 log. Okay, sorry. It's going to look like y is equals to log to base 2 of x. So this is the inverse of that. Please let us not confuse these. The inverse of an exponent with an inverse of quadratic, for an example. The inverse of a log will always be the inverse. The inverse of a log will be an exponent, and vice versa. The inverse of an exponent will be the log. And when you interchange, we play around with x and y. Please recall that the base of an exponent will remain the base even in the log, because this is how we write our base. This is the base now, and that was the base. So as long as you can have in mind that the base of an exponent and a log remain the same, then yours is to play around with y, having to turn y into the subject of the formula, which I don't think is going to be a very difficult exercise indeed. Now, that was 5.3. That was when I was answering 5.3. It only carried 1 mark. It only carried 1 mark because there is no much of a work to be done here. Right, let's quickly go to 5.4, wherein now it says you must sketch the graph of the inverse of f on the system of x's on the diagram sheet provided. Right, for you to be able to sketch that, please remember, you go back to your function graph to say, what was the intercept of the y-intercept of the function, the y-intercept of the function, the intercept of the function with the y-axis. It intercepted with that at point 0 and 1. Now it means the inverse must be such that intercept with the x-axis this time at 1 and 0. At 1 and 0. That should be the golden rule that will help you draw that graph. If this has intersected, if the main function, if the function has intercepted the y-axis at point 1 and 0, then it means the inverse of that will, sorry, not at 1 and 0. If the function has intercepted the y-axis at 0 and 1, then it means its inverse will intercept the x-axis this time at point that has coordinates 1 and 0 because they are interchanging. Right. Now, it means for you to be able to draw such a graph, this is what we need to do. Let me quickly have this graph on my page. I can only have, let me have 1 here. If I have 1, I can have 2 here, have 3 here, and have 4 here. Then I'll have my 1 here, my 2 here, my 3 there, and my 4 there. Fine. This is a point now that consists of coordinates 1 and 0. Remember that point consisted of 0 and 1, at which the function has intercepted the y-axis at. Now this one must intersect the x-axis at this point, and this is the shape that it has to take. That is the shape that it has to take. Right. And in addition to that, we can always, if we want to be sure that this is indeed the inverse of that, we can always draw the line of symmetry between the two graphs, the line such that defined by y being equals to x, wherein this must be the mirror image of that. What I like most about this question is that sometimes they used to say, indicate the x-intercept. I've indicated the x-intercept. Indicate the x-intercept and the coordinates of one point on your graph. This is very specific. Indicate the x-intercept and the coordinates of one other point on your graph. Right. Now this is where I am. Let's have a look at this. Now, because this is a function graph. This is a function graph, and this is the inverse graph. When you look at this, let's look at this point, because we want to. I want us to answer this question. The second part that says, and the coordinates of one point on your graph, which must also be indicated. When you look at this graph, this point has coordinates 1 and 0. It has coordinate 1 and 0. The next point that I'm going to spot on the inverse must be such that it is the y coordinate is 1 less unit than the x coordinate, just like it was the case here. Let's come back here. When you look at the coordinates 1 and 0, 0 is 1 less unit than the x coordinate. So if I'm going to indicate another point on the graph, that point must have a x coordinate which is going to be greater in 1 unit to the y unit. So if I take this one for an example, the coordinates at this point should be 2 and 1, which answers that. It's because it has specifically say indicate the x-intercept, or indicate the x-intercept. We have already answered that, and the coordinates of another point on the graph. So this is how we do that. This is going to be our x, and that is going to be our y. In this case, we are saying if this point is such that the x is 1 unit greater than that one, the following point must also be, the x must be 1 unit greater than the y coordinate. And hence, that is the point that is going to carry that in answering that. Let us be careful of that, because this is one of the questions that the examiners like asking. Fine. Now, can we quickly go to 5.5? In 5.5, if you look at 5.5, it says write down the equation of h if h of x is g into x plus 1 minus 2. Write down the equation, the new equation of h of x. Now, how do we do this? How do we do this in answering this question, which is 5.5? Because this one was actually our 5.4. This was our 5.4. Let me write it down. That was 5.4. Now let's go to 5.5. I hope we can all see that. Let's go back to 5.5. In 5.5, the question says, let me go. Question, write down the equation of h if h of x is equals to g of x plus 1 in bracket minus 2. Write down the equation of h if h of x is equals to g of x plus 1 minus 2. And that question carried 2 marks. Fine. Now, for us to arrive there, we normally say this. Okay, if I've got to write my h of x, my h of x will look like this. I'm going to have my g of x. What is the definition of g of x? My g of x is, if I can take the memory lane, my g of x. What is my g of x? My g of x, this is my g of x. This is my g of x. This is my g of x. Fine. Now what we are going to do, we are going to say h of x is equals to negative x minus 1. Remember, that was my g of x. Let's go back. This was my g of x. Minus in bracket x minus 1 plus 1, because that is basically what this implies. It says I must add 1. I'm adding 1. We're having our g of x, and on this g of x we are adding 1. And I'm closing the bracket. I'm saying it's now plus 2. My g of x has plus 2. I'm writing that to positive 2. But I'm reminded that this we must also subtract 2. So I'm writing negative 2 here. Remember, this is squared. That is squared. Fine. Now what happens inside the bracket? The positive 1, let me do this, sorry. The positive 1, what happens in the bracket? This is now my h of x. What happens in the bracket? The positive 1 will cancel with the negative 1. So it leaves me with what? With x. So it means, and outside the bracket, the positive 2 will cancel with the negative 2. And what am I having inside the bracket? I'm having x squared. I'm having x squared, which is what? Which is my h of x. But now I must open the bracket, so it means I must multiply everything by negative, the negative which is outside the bracket. Therefore, it means the equation of h of x is going to look like negative x squared. So that is the new equation. That is the new equation for h of x. That is the new equation for h of x. I hope we have got that one right. Right. I hope we have got that one right. Now let's go to this question. It says 5.6. Let's look at question 5.6 now. How can the domain of h be restricted so that h prime of negative 1 will be a function? How can the domain of h be restricted so that h prime of negative 1 will be a function? Right. Let's go back to the equation of h of x. This is the equation of h of x, which is a parabole. This is a parabole. I mean, if we are to to have this graph, if we are to scribble this graph, or the graph defined by this equation, is going to be a y, x, x. A is negative, so the graph is going to face downwards. A is negative, so the graph is going to face downwards. So it means this graph is tend to look like this. It's tend to look like this. Remember, it does not have its intercept with both x and y are 0. So this is how this graph is going to look like. This is how this graph, the graph defined by this, is going to look like. Now, we are faced with a question that says, how then, how can the domain of H be restricted so that this becomes a function? I mean, if we look at this, if we look at this and we want to draw the inverse of this, the inverse of this can look like this. It can be something that look like that. It can be something that look like that. Now, we must not forget, or it can look like this, or let me do this. Let me do this. Let me have another drawing so that we understand fully what's going on here. We say since it's doing this, since it's this, remember when you talk of the inverse must always be about the line y is equals to x. About the line y is equals to x. Fine. If we don't do it that way, we can always do it this way. I think the correct one will be this one. Yes. Even though this one, this was supposed to go on. I mean, this is just a scribble. I know you understand what is going on here. So now here, let's talk about the graph. If we go to the horizontal line test, we want to test the main function, whether or whether this relation is a function or not. We draw a horizontal line test. It cuts this at 1, so it means this becomes a function. And we have another horizontal line test to test whether this relation, the inverse, is a function or not. We draw a horizontal line, and if it cuts it at more than 1 point, it means this is not a function. So now we must, however, try to make this a function. So the question that we are faced with is, how can the domain, let's go back to the question, how can the domain of H be restricted so that H prime of -1 will be a function? At the moment, it's not a function because of the line test that I've just carried out on the inverse. It's not a function. However, what is it that you can do? It means you must put up some restrictions on what? On the domain, the x values. We must put on the restriction. So the domain must be such that, I mean, we all know that if we can do away with, let me hide this. If I hide this part, when you look at this, this is still the part of the whole inverse. If I hide that part and I apply my horizontal line test, it means the horizontal line test is only to cut on this at once, so it means it's going to make this a function. Or if I hide this part, we still have this part of the function or of the graph, and if I also carried out the horizontal line test, it only touches this at 1 point, so it makes this one a function. So now, how do we put in the restrictions in terms of the domain? We say this will be a function provided that x, I mean, if this is the origin, provided that x is greater, all right, let's start with this, provided that x, because if we take it here and we go this way, it means we are having decreasing values of x as accordance to this part. So it means x must be less or equals to 0. X must start here. X must be less or equals to 0. Yes, X must be, no. This is not correct. This is not correct, because if you check on here, yes, for this part we can see that this X is less or equals to 0, because if this is the origin and we are going this way, it means we're having decreasing values of X. We're having decreasing values of X. Fine. Which I think for me is going to be the same story even on this, because on this part X is still starting from 0 to that. So the restriction must be such that X is less or equals to 0 in answering 5.6. In answering 5.6 we say the restriction is such that X should be less or equals to 0, implying that if we concentrate, but we must only concentrate on this. We must only concentrate on that. Or maybe we can go back to the question. Yes. I think that is what the question wanted. I think that is what the question wanted. We are now going to have 10 minutes break. We'll come back after this 10 minutes. Thank you. Boys and girls and colleagues, we are still busy with our inverse functions, and since this is a revision exercise, we are not teaching, but we are treating previous question papers. The question paper that I'm having in front of me is of February and March 2009, and the question that we are going to look at for now, it's question 7. It's also an inverse function question. Right. It reads as follows. The graph of h of x is equals to a raised to the power of x is sketched below. A is a point on the graph, and it has coordinates 1 and 2. A is a point on the graph and has coordinates -1 and half. -1 and half. Now, the first question that we come across there as 7.1, say, explain why the coordinates of Q are 1 and 0. Let's check where point Q is. Point Q becomes the y-intercept of our graph. So it means we already have the coordinates, according to this statement. We already have the coordinates of this point, which are S, 0, and 1. But you must explain why the coordinates are of point Q are 1, 0, and 1. Now, let's check on what we can do in answering 7.1. Let's see what we can do in answering 7.1. I mean, the first thing that we realize with that point is this point, for it being the y-intercept of this, the x coordinate must of course be 0, because anywhere along the line on the y-axis, the value along the y-axis, the value of x is 0. So this is the first thing that you observe. And they now say this must be what? This must be, the y-coordinate must be 1. I mean, let's go back and check on this. it is an exponential graph. Now for it to be an exponential graph, we can do the explanation by calculating to say what happens if we can take our equation, the equation h of x, which is equals to a raised to the power of x, and say, because at this point we're having 0 and 1, if we can determine h of 0, that will be equals to what? It means I'm substituting x with value 0, because I'm looking for what? I want to confirm that indeed this is equals to the coordinates of Q are 0 and 1. I've been given that, so I want to confirm that. Right, if I'm having my h of 0, that will be equals to what? That will be equals to a raised to the power of what? Raised to the power of a raised to the power of 0, because I've substituted x with 0. Then I quickly recall that what is anything raised to power 0? Anything raised to power 0 is 1. So already I'm having my y coordinate indeed as 1. So I have done this by calculating, and therefore I can say, since that is the case, I can therefore say, therefore Q, the coordinates of point Q indeed are 0 and 1, since my h of 0 has gave me 1, h of 0, which is my 1, which is my y. Fine. Or I can say, if I don't want to answer it in this way, I can have an alternative to say any base raised to the power of 0. Any base raised to the power of 0 is equals to 1. We know that from exponents. Any base raised to the power of 0 is equals to 1, which gives me a raised to the power of 0 be equals to 1. So I think that one was so simple. Let's go to 7.2. 7.2 say to me, calculate the value of a. Calculate the value of a. Where? Calculate the value of a where? The value of a from this equation. The value of a. H of x, which is raised to h of x, which is equals to a raised to the power of x. And what are we going to use to determine the value of a? We are going to use the coordinates of point capital A. And what are the coordinates of point capital A? Sorry. What are the points of point capital A? Are -1 and half. These are the points that we are going to use to determine what? To determine the value of A. Now, we mustn't forget that h of x can always be y. If I can write this in terms of y, it means I'm having y being equals to a raised to the power of x. Then why am I doing that? Because I'm having this point with coordinate -1 and half. I'm having this point with -1 and half, where -1 is my x and half is my y. Then it means I must come and directly substitute them in here. Where in now 1/2 will be equals to a raised to the power of -1. Right. Remember, I'm here to determine the value of a as requested by the question, 7.2. Now, when I do this, I say 1/2. If I write this in terms of a fraction, it means I'm going to have 1/a. Now here, what I'm going to do is, I must now get rid of a. Yes, I'm saying get rid of a. How do I get rid of a? I'm multiplying everything by a. If I multiply by a this side, I must multiply by a that side. So this a will cancel with that a. Here I'll be having a/2, which is now equals to what? Which is now equals to 1. But when I arrive here, I say, but I want to solve for a. I want to solve for a. So I can further say, let me get rid of these 2. And the only way of getting rid of these 2 is to multiply everything by 2. That is both sides. So when I multiply by 2, I must multiply by 2 here. These 2 will cancel these 2. Therefore, 1 multiplied by 2 is 2, and hence A is equals to 2. Hence my A is equals to 2. Fine. That was the answer for 7.2. Let us go to 7.3. 7.3 says write down the equation for the inverse function h prime of -1 in the form of y. Right. Before we can do that, I think it is proper and logical to write now the whole equation of the function, the whole equation of this, because now we have got the value of A. So what we need to do is to say, therefore, h of x will be equals to 2 raised to the power of x. This is the equation that defines this function, this graph. It is the defining equation of this graph. So maybe I can write it here and say h of x is now equals to 2 raised to the power of x. It is the equation that now defines this, because remember we are not given that, but we have, since we have determined the value of A as 2, we can write it as a complete that. Now, why are we allowed to write that, or are we expected to write? It's because in answering this, we must have a complete equation. Fine. Now, as I said it earlier on, I've said when we have a function that looks like this, an exponential function, the inverse of an exponential function is going to be a log function. And in case you are interchanging your x with your y, remember always that the base of the exponent will become the base of the log, since the inverse of the exponent becomes the inverse of the exponent becomes the log function. Right. So now that we have this, we can say if we write this in terms of y, we're having y being equal to 2 raised to the power of x. Then we interchange them. We are going to have x being equals to 2 raised to the power y. Right. Now from log knowledge, solving this implies engaging the logs. Now when we turn the y into the subject of the formula, y will therefore be equals to log. To what base? The base of the exponent remains the base of the log. Base 2 of what? Of x. So this is the inverse. That is the inverse, which answers 7.3. Let's quickly go to 7.4. 7.4 requests of us to draw the inverse. I mean, if we have a look at this as the intercept of the main function of h of x, the inverse of this as the log must intercept the x at point that now is going to have coordinates 1 and 0. In essence, what I'm trying to say, I'm saying this point should be the mirror image of that. This must be the mirror image of that. Now, and this is how it's going to look like. This is how it's going to look like. We're having 1 and 0. Here we're having 0 and 1. Maybe we can take it further to say the value of x at this point is 2, and the value of x at this point is 3. Why am I doing this? I'm doing this because I want us to come to an understanding that this question will always indicate, will always request you to the coordinates of 2 points that lie on the graph. This time it says 2 points which lie on the graph. All right, maybe if I can have this as 4, because this, remember, was not drawn up to scale. This was not drawn up to scale. Then it means I'm going to have my 1 here, and I can have my 2 there on the y-axis. Because this one requests of us to have 2 points. My first point will be the point that has coordinates 2 and 1. And the next point will be the point that has now coordinates. Let me take it a little bit further, because remember this was not drawn up to scale, but you'll be expected to do that in the exam. The next point will be this point, which has now coordinates 4 and 2. I mean, let's go back and say, let's come here and say, maybe we can use these 2 points. This point has coordinate 1 and 0. Remember, we have said that the next point should always, the y coordinate of the next point should always be one unit less than the x coordinate. So this is the point. That is that point. That is that point. Yeah, maybe this should be 3. I think I was wrong here. Should be 3, so that we're having 3 and 2. It must always be 1 unit less. So maybe we can take this as 2 points, or we can just take that as 2 points. But please, you need to indicate that as when you are requested of that. It's very, very important that we indicate those. You'll be doing that, since you'll be doing that, you'll be drawing accurately, so because you'll be given the diagram sheet. Here, I'm not using a diagram sheet. I hope we can all see. Let's carry on and say, if we go to 7.5, it says, read off from your graph the values of x for which log to base 2 of x will be greater than 1, will be greater than negative 1. Read off from your graph. Read off from your graph the values of x from which log to base 2 of x will be base 2 of x will be less than negative 1. When we want the values which are greater than negative 1, where y is going to be negative 1, I mean, when we check on here we are, firstly we are talking about y. When we are at the origin, upward, y is going to be greater than positive 1. But if we are here at the origin and go downwards, y is going to be less than negative, y is going to be less than 0. Here, y is going to be greater or equals to 0. If we move from here upwards, y is going to be greater than 0. Obviously, it's going to be greater than 1. Obviously, it's also going to be greater than negative 1. But if we move from here downwards, y is going to be greater, it's going to be equal or less than negative 1. That is what we need to do. However, if we come back and say, if we want to have negative 1 here, remember the question says, read off from your graph the values of x for which the log to base 2 of x, that is for this graph, will be greater than negative 1. Will be greater than negative 1. If we are here, values which are beyond this negative 1, on this side of negative 1, are obviously less than negative 1. But from negative 1 here, values in here are greater than negative 1. That is between negative 1 and 0. But we must read that from what? From the log graph. We must read that from the log graph. Fine. Maybe if we can have a look at this, I think I can use this explanation for this answer. We are having negative 1 here. We are having negative 1. And this is the inverse function. That is our inverse function. Fine. This being our inverse function, if we are here, just at the center, that is in between 0 and negative 1, the value of y should be negative 0.5. Should be negative 0.5. Should be the value of x here should be 0.5. Should be 0.5. At this value, it should be 0.5. That's why we are going to have that. Now, we are all looking for values we are all looking for values which are going to make this greater than negative. So obviously it's going to be values which are greater than negative, which are greater than 0.5, positive 0.5. If you move this way, that way. If you move this way, that way, all those values will make the function to be greater than negative 5. So it means in answering that question we say x should be greater than 0.5. X must be greater than 0.5 because we are reading that from the graph. Right, let's quickly go to the next question paper. At this point in time, I'm looking at this question paper. I think maybe we can take, let's take the 2012 question paper. I'm trying to cover as many questions as I can. It's question 5. Question 5, it's of 2012, November 2012, which reads as follows. It says, the graph of f of x is equals to negative the square root of 27x for x being greater or equals to 0 is sketched below. This is the graph. And this graph has a point P with coordinates 3 and negative 9. This has coordinates 3 and negative 9, this point P. What is the first question that you come across? The first question says, use the graph to determine the values of x for which f of x will be greater or equals to negative 9. For which y, f of x is a y, for which y is going to be greater or equals to negative 9. Fine. Use the graph. Use the graph to do that. Right. Let's come here. We are looking for the values of x. What happens if x is equals to, what happens if x is equals to 0? If x is equals to, yes, maybe we can start from 0. What happens if x is equals to 0? Where? It means you are here. What happens if x is equals to 0? It means if we come and substitute that x by 0, we are going to have f of x, which is now going to be equals to minus the square root of 27 by 0. Anything multiplied by 0 is 0. So it means f of x is equals to 0. F of x is equals to 0. So it means if we start with x as being 0. Why do we start here? Because this is where our graph starts. We cannot start beyond this point. Our graph starts there. So now it means 0 is one of the elements of that interval. Fine. What is going to happen maybe if x is equals to 1? We are trying to read that from the graph. We are satisfied with the value of x being 0. What happens if x is equals to 1? Let's check. If we put in, we say f of x, if f of x is equals to negative the square root of 27 by 1, what is the square root of? Is going to be a negative number. So it means what is going on here? F of x is going to be equals to negative the square root of 27. If we check on, if we can use our calculator to determine the square root of 27. Let's check on the square root of 27 with our calculator. 27 does not have a perfect square, remember? 27 does not have a perfect square. If we say 27, the square root thereof, the square root, it's going to be a negative number anyway. It's going to be a negative number. It's going to be a negative number, which is going to be less, which is going to be greater. Let me see. This is going to be greater than negative 9. It's going to be greater than negative 9. So we are saying negative square root 27 is greater than negative 9. It's greater than negative 9. So it means 1 is admissible. It forms part and parcel of that interval. We've started with 0. Now we are at 1. I've substituted that with 1. What happens if we have 2? If we have 2, we are going to have 54 inside. 54 inside. So negative, the square root of 54 is also going to be greater than negative 0. And what happens? Negative 9, sorry, there's no negative 0. Negative 9 is also going to be greater than negative 9. So it means 2 is also admissible in that we started with we started with 1 and we substituted 0. We started with 1, 0, and we went to 1. That is when we are coming down until we are at 3. We want to see what is going to happen at 3. If we substitute that with 3, it means you are going to have 27 multiplied by 3, which is going to give us 81. Which is going to give us 81. So what happens at 81? At 81, what is the square root of 81? The square root of 81 is 9, but we have in negative 9. So negative 9 is equals to negative 9. So indeed, we can say we can't go beyond that. So it means this values of x would be x is an element of closed interval 0 and 3. Because both from the number 0 to 3, that was admissible. I mean, we started with 0, that is what we have got. Then we started with 1. Negative 27 is greater than the square root of negative 27 is indeed greater than 9. The square root of negative 54 is indeed greater than 9. And the square root of the square root of 81 is 9, and negative 9 is equals to 9. So it is only up to that. That is the question. That is the answer to that question, to 5.1 of what question paper of November 2012. That was the question, the answer for 5.1 for November 2012. Now let's go to this one. Let's go to this one. The one that says write down the equation of the function, the inverse in the form of y. Include all restrictions. Include all restrictions. Write down the equation of that, the inverse of that. Right? What is the function? The function reads as f of x being equals to negative the square root of 27x. That is that. That is our function. So we want the inverse of this. We want the inverse. And in this, I must include all the restrictions. Fine. Remember that my f of x can always be what? Can always be y. Let me write it in terms of y, such that when I do my interchanging, we don't have any problem. We don't have any problem. 27x. So the first step here is to interchange x with y. I'm interchanging that. I'm having x, which must be equals to negative square root of 27. Or maybe what should be the first step? Okay, let me not rush to this step. Let me first do this and say, since y is equals to negative the square root of 27x, what happens if I can say, if I will look for y squared? My y squared will be equals to 27x. That is how my y is going to look like. Then if I have to interchange x with y, then it means I'm going to have my x here as being equals to my x here, as my x squared here as being equals to 27y. Fine. But when I'm here, I recall that I must always turn the y into the subject of the formula, because this must be written in terms of y. So it means I must say y will therefore be equals to what? Will be equals to x squared over 27. And this should be my inverse function equation. This should be my inverse function equation. Let me take it back, guys. Let me take it back because I don't want you to struggle with this. We're having this question. We're having this equation. We're having f of x as being equals to negative the square root of 27x. And I've said, okay, because I know my f of x is y, I think it is going to be easier for me to work with f of x as y rather than as it is. So I'm writing that as y being equals to minus the square root of 27x. But when I arrive here, I'm saying, okay, since y is equals to the square root, I can always square both sides. If I square both sides, it means I'm going to have y squared here. It means I'm going to have y squared here. So it means I'm going to have y squared. If I'm squaring both sides, this side now is going to give me what? 27x. Because I've squared both sides. Remember, this root sign squared is going to give you that. The negative gives you the positive, hence we have a positive. Right. But when we are here, we are saying, but we mustn't forget that we have to interchange x with y. Interchanging x with y, it means I'm going to have my x squared here, which is going to be equals to what? 27y. Then turning the y into the subject of the formula implies that x squared will be equals to x squared over 27, because now I'll be dividing by the coefficient of y. And what I do on the left, I must also do it on the right. So it means my y will be equals to that. So this is going to be the equation of the inverse. However, I've been requested also to do what? To include all the restrictions which are going to make the inverse a function. Because however, this function, the other way of writing this function is by having to say 1 over 27 x squared, which is equals to y. That is the other way of writing it, if you don't want to write it this way. Now, they didn't ask us to draw it. However, they say we must table down the restrictions which are going to make this a function. Remember, if I have to draw this thing, if I need quickly to draw this thing, this is how it is going to look like. It can look something like this. Why am I? Is it concave up? Because a is positive. It can look something like this. However, now we want to make this a function. If this is going to be the inverse of that, obviously the inverse is not going to be the function. So what we need to do, we need to put in the restriction that will eventually make this a function. Now our restriction in this case say that the restriction should be such that x is less or equals to 0, or we can say x is an element of open interval negative infinity up to 0. So these are the restrictions which go hand in glove with that. This was not an easy question. I must confess, it was not an easy question. Right. Now let's go on to 5.3. 5.3 now requests of us to sketch the inverse of the function in our what is this? In our answer book. What I think we can do here is to do this. On this, we can have our line defined by y is equals to x. y is equals to x, such that the inverse of this function becomes the mirror image of that, which is going to be something that looks like this. Which is going to be something that looks like that. Why am I saying this? Oh, this now, if this becomes the mirror, this part will be the mirror image of that. Now, why am I saying this? I'm saying this because of the restriction that I've already tabled down. I've said x must either be equal or less than 0. I mean, if we move from here, that side, x is equals to 0 here, and x is going to be less, as prescribed by the interval. The interval says x must either be equals to 0 or less than 0, or x must be an element of negative infinity, open bracket, negative infinity, up to this. So that is going to be the inverse of that function. That should be the inverse of that function. Right. I'm left with 20 minutes, and I want to take yet another question. I want to take yet another question paper on that. I'm hopeful that your educators will help you further with that, because the reason why we are doing this is because these are some of the questions which are referred to as set piece questions, at which you must accumulate almost a total in that. Let me take this question paper. The question paper that I'm going to have in front of me, it's February, March 2014, the supplementary examination question paper. It reads as follows. Given the graph of g of x being equals to log to base 1/3 of x, A is a point, A is the intercept of G, A is the intercept of G, and P with coordinates 1/9 and 2 is a point on the graph. It's a point on the graph. Let me also repeat that. I'm saying question 8 of 2014, February, March. It says you are given this, g of x being equals to log to base 1/3 of x. A is just a point in the x-intercept on G. And P is another point, but this time P has coordinates 1/2 and 1/9 and 2. Fine. Much as I refer to this as a point, this point has coordinates, and the y coordinate here obviously is going to be 0. Fine. We realize that this is now a log graph, and the inverse of a log graph is going to be the exponential graph. Fine. We'll take it further. The first question now says, write down the coordinates of A. If we go back a little bit with the inverse graph, the inverse will always intersect the y-axis where at a point that has coordinates 0 and 1. 0 and 1. The exponential graph will always intersect with the y-axis at a point that has coordinates 0 and 1. So now if this becomes a mirror of this, if this point becomes a mirror, I mean, if this is going to be our exponential graph, the inverse graph, the log graph, will intersect that at what point? Right, let's go back. Point A, if the coordinates of this point are 0 and 1, the coordinates of this must be 1 and 0 because that relates an inverse. So it means the coordinates at this point must be 1 and 0. If we take it from the exponential, because we always advocate that the exponential with the y-axis intercept the y-axis at a point 0 and 1. So the log graph must intercept with this at 1 and 0. And that carried 1 mark. Right. 8.2. Sketch the graph of G of -1, indicating the intercept of the axis on and 1 one other point on the graph. That will always be emphasized. I mean, this is the third question from previous question papers that always carry out this thing. So it says we must emphasize. It says we must be able. I think this was not correct, colleague. Sorry. We must be able at this point in time be able to draw the graph. But before we can sketch the graph, we must first determine the equation for that. The equation for that. If this was the equation for the main function, the g of x, if the g of x was equals to log to base 1 over 2 or 1 over 3 of x, if you want the inverse of this, the inverse must be an exponential. Remember, to make life easy, we can always turn this into y, write it in terms of y, then we have log to base 1 over 3 of x. Then we can always say the base of a log will remain the base of an exponent. The base of a log will remain the base of an exponent. Now it means if we are going to write this in terms, if you want the inverse of this, it means you are going to have y being equals to 1 over 3 raised to power x. That is the equation of what? The equation of the inverse of that, which is the g prime of -1. Right, now to answer that, now they say sketch that. Sketch. All right, for us now to sketch the inverse, we must always do this. Our starting point should be the line y is equals to x. If we have this, then we will not have any problem whatsoever. We will not have any problem whatsoever, because what we are going to draw now, we are quite aware that the coordinates at this point is now what is this? 0 and 1. 0 and 1. So if we draw the inverse, of that, it may take this form. The inverse of that will take this form. Fine. Why do we say it takes that form? All right. Maybe I should have drawn my such that it intersects with that at that. I don't think this is going to do well for me. Let me rather explain this having this. If we go back to this question, remember we were given 1 and 0. And I've just explained to you that this point now is going to have 0 and 1 because it should be the mirror image. This point had what? Had 1 over 2. Now the mirror image of this must be here. The mirror image of this must be here. And the coordinates, we also interchange them. The coordinates of this point, which I'm going to refer to it as B, must be such that is 2. Is it going to be 2? Yes, it's going to be 2 and 1 over 9. Because we are just interchanging them. I'm sorry for this mess that I've created, but this is basically how it should look like. And this is basically our inverse. This is how the inverse should look like. Fine. Now this question 8.3. Let's check on 8. Quickly look at 8.3. 8.3. We are left with 5 minutes before the end of this presentation. 8.3 says write down the domain of this, the domain of the inverse. Write down the domain of the inverse. I mean, if this is our inverse, we realize that this inverse can be extrapolated to negative infinity to positive infinity. So the domain will be real numbers. The domain of that will be real numbers because it ranges from the negative infinity to the positive infinity. So the domain for that will be real numbers. February, March 2012. We are given the equation, the function. F of x is equal to 3 to the power of x. They say determine the equation of the inverse. This should be very simple. It carries 1 mark. It should be a very simple exercise. It carries 1 mark. Remember what I've always said. I've always said the inverse of that is a log. And indeed, that is what we are going to have. Now, when they say we must sketch that, sketch in your answer book the function and the inverse. It means you would have had the function and the inverse, and this is what you will be expected of doing. Please remember that this point must be the mirror of that through the line y is equals to x. Log graph, exponential graph. Right. The next question talks about the domain of the inverse. It says write down the domain of the inverse. The domain of the inverse will be x will be greater than 0 because it must be, and it excludes 0 because at 0 we have the asymptote. So it means x will be greater than 0, anything beyond that, greater than 0. Boys and girls, and you colleagues, I can only wish you good luck on paper 1. Please, whatever I've done here, let it serve as a foundation of what we are going to do in our revision. I must emphasize that this paper, this part that I was doing, is the part that consists of the set piece questions, and these are the questions that all learners, irrespective of their levels, must be able to pass and do well in it. My last advice to you is that remember that in this section you'll always be having exponential graph, exponential function, which you will be requested to determine the inverse, and the inverse in this case is going to be a log. Or be given the log, and the inverse there should be an exponential, and you'll also be given the parabole, which of course will be expected to determine the to table down the restrictions. With those few words, boys and girls and you colleagues, good luck in the coming exam. I thank you.